Horizontal alignment part 6. In lesson 11, we discussed about the ASHTO approach for transition design control, considering both tangent to curve transition, that means without any transition curve in between, and spiral curve transition, that is a spiral curve in between the tangent and the circular curve. After completing this lesson, the student will be able to appreciate the need for extra widening of pavement on horizontal curves, understand the IRC as well as ASHTO approaches for design of extra widening of pavement on horizontal curves, and also the student will be able to understand the general controls for highway alignment. Let us start with the need for extra widening on horizontal curves. Why it is necessary to provide extra widening on horizontal curves? There are primarily two broad reasons. One, off tracking of vehicles. Number two, psychological reasons. So, there are two aspects. One is the off tracking of vehicles, and the second is the psychological aspects. Broadly, because of these two reasons, it is necessary to widen the road pavement on horizontal curves. Now, let us try to understand these two aspects. First, off tracking of vehicle, and then psychological aspects or psychological reasons. Automobiles have rigid wheelbase, and for all these vehicles only the front wheels are turned. When these vehicles negotiate a horizontal curve, the rear wheels do not follow the same track as that of the front wheels. That means, for all these vehicles with rigid wheelbase, when they negotiate horizontal curves, the path followed by rear wheels and the front wheels are different. This is known as off tracking of vehicles. Off tracking means rear wheels and front wheels, they do not follow the same track. Obviously, for a tangent sections, we expect rear wheels and front wheels, the tires, they should follow, we expect them to follow the same track, but on curves they do not follow the same track. Now, a road system is designed for the design speed. So, when the vehicles are traveling at low speeds and maybe up to the design speeds, we do not expect any lateral slips for the rear wheels, because the road system is designed to support the design speed up to the design speed. So, we do not expect any lateral slip of the rear wheels. Now, in this case, the rear wheels normally will follow the inner side of the curve. That means, whatever path will be followed by the front wheels, the rear will follow the inner side path. That means, if we consider the front inner wheel on the edge of the pavement, then the rear inner wheel will be on the shoulder. Okay. So, that means that is basically off tracking is occurring and the inner wheels or the rear wheels follow the inner path of the curves as compared with corresponding front wheels. Now, suppose the vehicle travels at a speed higher than the design speed. Now, obviously, a road system is designed for the design speed. So, we normally do not expect vehicles to travel at a higher speed, but if vehicle travels at speed higher than the design speed, then the super elevation and the design side friction will not be adequate to support the centrifugal force which are in operation or which are effective on vehicles on horizontal curves. In that case, transverse skidding is possible and rear wheels may follow the outer path as compared with corresponding front wheels. So, in this case, if the vehicle is travelling at a speed higher than the design speed, we do not expect rear wheels to follow the inner path as corresponding or as compared with corresponding front wheels. Rather, in this case, the rear wheels may follow the outer path as compared with front wheels. That means, altogether, whether the rear wheel follow the inner path or the rear wheels follow the outer path, one thing is very clear, that when vehicle negotiates a horizontal curve, rear and front wheels, they do not follow the same track. That means, off tracking of vehicles will occur. Now, what happens when there is a trailer? In case of a trailer, the path traced by the wheels of a trailer may be on either side of the central path of the towing vehicle. It may be on the inner side, it may be on the outer side with respect to the central path of the towing vehicle, depending on speed, rigidity of universal joints and other factors. So, in this case also we expect off tracking. That means, off tracking is a phenomena which is expected to happen for almost all vehicles which are travelling at a lower speed than the design speed, which are travelling also at a speed higher than the design speed. Even for trailers, off tracking is expected. So, the design aspect or the design of curves or road design must consider this aspect, and accordingly there is a necessity to widen the road pavement on horizontal curves. Now, this is one aspect, or say due to off tracking what is happening. There are psychological reasons also. When the vehicle is on tangent, we expect the vehicle to follow the central path. When the vehicle is moving on tangent, we expect the vehicle to follow the central path. But when vehicles are negotiating a horizontal curve, drivers have a tendency, when the vehicle is entering into the horizontal curves, drivers have a tendency to take the outer side of the lane. Drivers have a tendency to follow or to take the outer side of the lane. This is predominantly for two reasons. One, basically to take path with larger radius. So, the turning, while turning the vehicles, the drivers want to feel comfortable and also to have greater visibility. You know that visibility is a problem when vehicles are negotiating horizontal curves. So, restriction to side distance, restriction to visibility occur when at horizontal curves. So, therefore, vehicles tend to take the outer side of the lane when they are entering into a horizontal curves. Number 2, even on tangent, vehicle keep some lateral clearance. When two vehicles are crossing or passing each other, they keep some minimum lateral clearance. This lateral clearance requirement, or drivers when they are crossing or overtaking two vehicles are overtaking, drivers tend to keep more lateral clearance on horizontal curves for psychological reasons. So, therefore, this is also necessary to consider these psychological aspects of drivers in the design process. So, therefore, to summarize, widening of road pavement is necessary primarily for two reasons. One is the off tracking of vehicles, that is rear wheels and front wheels, they do not follow the same track. So, therefore, it is necessary to widen pavement to account for the off tracking. Number 2, also for psychological or behavioral aspects of drivers, it is necessary to have an extra width. So, therefore, in the design process, this off tracking and psychological aspects must be considered, and pavement should be widened enough to have safe and convenient operation and operation of traffic to the same standards as it happens on the tangent section. Now, let us see how these aspects are taken into design consideration, how the design basis, or what is the basis for design. Now, obviously, we shall discuss two approaches, the approaches considered by the Indian Roads Congress and the approaches considered by AASHTO. So, therefore, design of extra widening, first let us discuss about the IRC approach, or the approach which is recommended by the Indian Roads Congress, or which are normally in practice in India. IRC considers two aspects. One is called the mechanical widening and the other is called the psychological widening. So, the total required widening is divided into two parts. One is called as mechanical widening, or the component of widening which is required due to mechanical reasons, that is nothing but the off tracking, and the other part is psychological widening, that means the amount of widening which is required for psychological reasons of drivers, that component is known as psychological reasons. So, it has basically two parts. One is the mechanical widening, this is one component, and the other one is psychological widening. Obviously, this mechanical widening component considers mainly the off tracking of vehicles. So, off tracking due to rigidity of wheelbase, this aspect is considered, and accordingly the required widening is estimated, which is known as mechanical widening. And in psychological widening, we consider the greater maneuverability of steering at higher speeds, this is one aspect. Also, the extra space requirement for the overhangs of vehicles which are basically projected. If we take the axles and the tires, the body, there is an overhang portion. So, extra space requirement for the overhang of vehicles, and also considering the greater clearance for crossing and overtaking vehicles on horizontal curves. So, considering all these aspects, we take into this component, we consider this psychological widening component. Now, what should be the values? Because we know the basis, but what should be the values? How much widening should be done considering this off tracking or mechanical aspects, and how much should be done considering or to account for this psychological aspects. Now, one can actually calculate the requirement of mechanical widening from, and simple equations are possible, can be derived. Let us see here the sketch. This is the line which is the path traced by the outer front wheels, path traced by the outer front wheels. I am showing it by the yellow line. Similarly, let us take that the path traced by the outer rear wheels, that is shown by this green line. We have already understood the requirements for or the off tracking mechanism. So, rear and front wheels, they do not follow the same track. So, yellow line indicates the path traced by the outer front wheel, and the green line indicates the path traced by the outer rear wheel. So, obviously, if R1 is the radius of curve, considering the path traced by the outer rear wheels, and R2 is the radius of the curve considering the path traced by the outer front wheel, then requirement of extra widening W m is nothing but R2 minus R1, these two difference. Okay. Now, if we consider this triangle OAB, maybe again shown by the yellow line, OAB. Okay. So, if we consider this triangle, A is the position of the outer rear wheel, B is the position of the outer front wheel, and O is the center of the curve, then OA square, this distance is nothing but OB square minus BA square. Now, OA square is nothing but R1 square, because OA is nothing but the radius of the curve considering the path traced by the outer rear wheels. So, this is R1 square. Similarly, OB is nothing but R2, the path traced by the radius of the path traced by the outer front wheels. So, this is R2 square, and AB is nothing but this length of the wheelbase, it is nothing but this distance, same as the length of the wheelbase. Okay. So, therefore, R1 square equal to R2 square minus L square. Now, R1 again is nothing but R2 minus Wm, where Wm is the extra widening. So, what we find here from this basic equation, we find Wm equal to L square by 2 R2 minus Wm. This is the equation what we can get. Now, this is approximately equal to L square by 2 R, because instead of considering R1 and R2 separately, we now take R as the mean radius of the curve. So, therefore, extra widening Wm equal to L square by 2 R. Instead of considering R1, R2 separately, we are now considering a single radius, what we can call as mean radius of the curve. So, it is L square by 2 R. Now, this L square by 2 R is the requirement or the required extra width, considering a single vehicle on a particular lane, a single vehicle on a particular lane. So, therefore, if we have a multi-lane system or multiple lanes are there, in that case requirements are also to be multiplied. So, if we have n lanes, then this requirement to be multiplied by n. So, therefore, for a multi-lane system, this requirement is nothing but NL square by 2 R, NL square by 2 R. This is the final form, where n is the number of lane of the road, R is the mean radius of curve, maybe in meter, L is the length of wheelbase or the design vehicle. In Indian condition, it may be 6 meter or 6.1 meter for commercial vehicles. So, that way we can get the required extra width considering the off tracking of vehicles. Of course, it is a very simple derivation. Now, for psychological widening, it is difficult to derive an expression logically. So, therefore, most of the cases in India, empirical formula is used, popularly used for calculation of the requirement considering psychological aspect, or what we call is that psychological widening. Now, for psychological widening, the required extra width is calculated like this. WPS is the psychological component, V by 9.5 root R. It is empirical formula. Here V is the design speed of the vehicle in kilometer per hour, and R is the mean radius of the curve, that is expressed in meter. And in this case, psychological widening, required psychological widening can be obtained in meter. So, therefore, total extra widening is nothing but mechanical widening plus psychological widening. So, that is nothing but NL square by 2 R plus V by 9.5 root R. So, one can actually calculate what is the required extra widening on curve, depending on the design speed and also depending on the number of lanes and the radius of curve. So, these are the three major components or influencing factors. Now, considering these aspects, that means considering the requirement of off tracking, considering the requirement of off tracking, that is nothing but the mechanical widening, and also considering the component that is known as psychological widening, Indian Roads Congress have given the required total widening on curves. Design table is available. Now, extra widening is expressed as a function of the number of lanes and the radius of curve. So, for 2 lanes, single lane, values are given depending on different radius, up to 20 meter, 21 to 40, 40 to 60, like that. For different range of radius, what should be the design value, that are those values are given. Now, these values are calculated considering mechanical widening and the psychological widening. Now, it is worthwhile to mention that for single length rod, only mechanical widening is sufficient, or then that is why only mechanical widening is considered, because during crossing maneuvers, outer wheels of vehicles anyhow have to use the shoulder, irrespective of whether the vehicle is on the straight or on the curve. So, whether on straight or tangent or whether on curve, anyhow the outer wheels of vehicle have to use the shoulders. Therefore, for single lane road, it is normally not required to consider the psychological widening component, and therefore, only mechanical widening component is adequate. For multi-lane roads, the pavement widening may be calculated by adding half the widening for 2-lane roads for each additional lane, because values are given in the table, IRC table for 2-lane road. So, therefore, for 3-lane, 4-lane like that, for multi-lane roads, the pavement widening may be calculated by adding half the widening for 2-lane road for each additional lane. So, that way one can calculate the required widening for any conditions as per the Indian Roads Congress procedure, IRC procedure. Now, let us see the AASHTO approach for calculation of extra widening. As per AASHTO approach, travelled way width needed on curve is normally denoted as WC. It depends on a number of factors, on a number of aspects. One, track width on curve, how much track width is required, this is denoted by U. Then it considers the lateral clearance allowance C. It depends on the width of front overhang of inner lane vehicle. Carefully observe this part, inner lane vehicle denoted as FA, and also the extra width allowance. Considering all these components, the required travelled way width on curve is estimated. Now, let us try to understand each of these components and see how this required or the total travelled way width on curves is calculated. First, the track width. Now, the track width is nothing but on tangent, the track width is nothing but out to out of tires, the distance between out to out of tires. The track width on curve is nothing but sum of the track widths on tangent plus the amount of off tracking. So, whatever width is normally required on tangent, that component plus the amount of off tracking, that together can give us the required track width on curve. So, it can be expressed by a simple equation like this: U equal to U1 plus R minus R root over R square minus sum of Li square, where U is the track width on curve, U1 is the track width on tangent. As per AASHTO procedure, it is 2.44 or 2.59 meter depending on the design vehicle. R is the radius of curve or turn in meter, and Li is the wheelbase of design vehicles between consecutive axles and articulation points. This is also expressed in meter. Now, how to calculate the wheelbase for a normal vehicle, say a standard truck or maybe a bus, okay, even for a car? It is easy to calculate this length of wheelbase. Obviously, the procedure may not be so simple if there are if we consider the articulated vehicles. Okay. So, in that case also there are procedures available, one can refer to a standard textbook or the ASTO manual to understand in details how exactly this Li is calculated, but Li is nothing but basically the wheelbase of design vehicles between consecutive axles and articulation points. So, that way one can, using this equation, one can easily calculate what is the requirement or what could be the width of curve on tangent. Now, this component u1 is the width, track width on tangent, that is simple, and this component is also simple. The way we have shown you the derivation for required widening when we were discussing about the IRC approach, exactly following the same or similar procedure, one can actually calculate the required this component. But ASTO has also made the thing simpler. This is the basis what we discussed. Considering this basis, ASTO has already given or produced design charts for calculation of track width on curves, and this track width is a function of design vehicle, because vehicle property, this Li value is very much dependent on the property of the design vehicle, and also it depends on the radius of the curve. So, considering different design vehicles, that means what are the different design vehicles and what could be the requirement for them, and also considering the radius of curve, ASTO give design charts for calculation of track width. So, track width a function of design vehicle and the radius of curve. Now, the lateral clearance allowance. Now, this lateral clearance allowance provides for clearance between the edge of the travelled way and the nearest wheel path, and also for the body clearance between vehicles passing or meeting. We have already discussed that the requirement of lateral clearance when vehicles are crossing or passing each other. Now, this lateral clearance per vehicle, ASTO has given specific value. Per vehicle, it should be taken as 0.6 meter, 0.75 meter, 0.9 meter respectively for different travelled way width on tangent equal to 6 meter, 6.6 and 7.2. So, depending on the travelled way width on tangent, which may be 6 meter, 6.6 meter, 7.2 meter, the lateral clearance per vehicle can be calculated. It is already given in ASTO. Now, width of front overhang. Now, what is width of front overhang? It is basically the radial distance between the outer edge of the tire path of the outer front wheel and the path of the outer front edge of the vehicle body. Let us see it again. It is the radial distance between the outer edge of the tire path of the outer front wheel and the path of the outer front edge of the vehicle body. Normally, if this is the vehicle body, let us consider a bus, then actual vehicle body may be, there is normally some level of projection, okay, some level of projection. Okay. So, what we are saying, when vehicle is taking the negotiating the curve, suppose if this is the wheel follows this path, then this edge or this corner will also trace a path like this. So, it is this difference radial distance, this difference up to this and up to this. That means, basically this difference. So, radial distance between the outer edge of tire, this is the outer edge of tire of the outer front wheels, and this is the path of the outer front edge of the vehicle body. So, the difference in radial distance is basically the width of front overhang. Now, this again can be calculated by this formula as indicated here, considering or making it as a function of the radius of curvature, front overhang of design vehicles occupying the inner lanes or inner lane, and length of the wheelbase. It may be mentioned that why we are, it is taken as inner lane or lanes, because the vehicle which is occupying the outermost lane, the vehicle which is occupying the outermost lane, for that vehicle the overhang portion need not be considered, because there is no travel lane or no lane, additional lane beyond that particular lane. Even if the overhang portion occupies some part of the shoulder, that may be still acceptable, because that is not another lane which may be occupied by another vehicle. So, therefore, this front overhang portion is considered only for the inner lane or inner lanes vehicle. Now, again for this part also, AASHTO has given design chart for FA, making it a function of the design vehicle and the radius of curve. So, for different design vehicles and for different radius of curve, what should be the value of FA, that may be obtained directly from AASHTO design chart. Now, the last component probably, that is the extra width allowance. It is again basically nothing but considering the psychological aspects or the behavioral aspects. This is the additional radial width of pavement to allow for the difficulty of maneuvering on a curve and the variation in driver operation. So, driver behavior and the variation in driver behavior is also considered, and the difficulty of maneuvering on a curve is recognized. But here again empirical formula is given. The formula what we have mentioned earlier when I was discussing about the practice in India for calculation of the psychological widening, I indicated another formula of similar nature. Basically, they will give very close value, that was V by 9.5 root r, and here in this case 0.1 V by root r. This is again empirical formula, where V is the design speed of vehicle in kilometer per hour and r is the radius of curve. In this case also, that is for extra width allowance, AASHTO design chart is again available, but in this case this extra width allowance is a function of the design speed and radius of curve, because you can see clearly this z is a function of v and r. V is the design speed, r is the radius of curvature. So, radius of curve. So, for various design speeds and also considering different radius of curve, the required value of z there can be obtained directly from AASHTO design charts. So, that way one can get the value. So, now we know all the individual component. So, what could be the widening or required widening of pavement on travelled way on curve? It is nothing but WC minus WN, where WC is the width of travelled way required on curve and WN is the width of travelled way on tangent. Basically, it is the difference between WC and WN. What is the width required on curve and what is the width required on tangent. Now, WC we have told that it is a function of the track width, function of lateral clearance allowance, width of front overhang of inner lane vehicles and the extra width allowance. Now, considering these aspects, 4 aspects, the width of travel to a curve can be calculated like this: n into u plus c plus n minus 1 into f a. Now, this u and c on per vehicle basis or per lane basis, therefore, they are multiplied by n, the number of lanes, and this f a, width of front overhang, I have already explained. This is only effective and meaningful to consider this aspect for all the inner lane or lanes, not the extreme outer lane. So, excluding the outermost lane, for all other lane this component is considered, and that is why it is n minus 1 into f a, plus z is coming from empirical formula. So, it is on a total width basis, that means not on a lane or vehicle basis. So, based on this we can calculate what is the required extra widening on horizontal curve following the AASHTO approach. AASHTO has also given tables. So, these are some of the values for 2 lane one way or 2 way highways. It depends on the radius of curve 300, 200, 100 like that, and also the roadway width or the travel way width. As I indicated earlier, it may be 6 meter, 6.6 meter, 7.2 meter required width on or the width on tangent. Then again for different design speed, what would be the actual total required extra widening. So, making the extra widening as a function of the radius of curve, the travelled way width on tangent and also the design speed. Now, normally a value less than 0.6, it is not necessary to consider a widening less than 0.6 meter. Okay. So, these values, table values, as we have discussed, it also depends on the vehicle type or the design vehicle. What is the type of design vehicle? These AASHTO tables or the values whatever I have indicated, they are basically for a particular type of design vehicle, that is W15. Now, for other type of design vehicle, AASHTO again gives the required adjustment factors. If it is other type of design vehicle, then what adjustment factors are to be applied? Those adjustment factors are also given. Now, this is for 2 lane, therefore, for 3 lane multiple 3 lane highway, these values are to be multiplied by 1.5. For 4 lane highways, these values are to be multiplied by 2 and so on. So, that way for different conditions, different design vehicle, different travelled way width on tangent, different design speed and different radius of curve, the values or the required extra widening on horizontal curves can be calculated following AASHTO approach. Now, let us see the application of widening on curves. We have understood the design basis for design. Now, let us see how those things can be applied. Curve widening should transition gradually over a length sufficient to make whole travelled way usable. That means, it should be introduced gradually in such a manner that the whole travelled way becomes usable. This is one consideration. The whole travelled way should be made usable. That means, the driver behavior or the path of driving, that should be recognized and that should be considered in the overall process. Then when a transition curve is used, increase the width at an approximately uniform rate along the transition curve and then the extra total width should be continued over the full length of circular curve. So, in that case the whole circular curve will have the complete extra widening. When no transition curve or the spiral curve is used, in that case provide 2/3 of the widening on tangent and the remaining 1/3 on the circular curve beyond the tangent point. For super elevation also a similar approach was taken. So, here also 2/3 1/3, sometimes it is 50%, that kind of distribution is done. Now, preferably widening should be provided over super elevation runoff length, but sometimes shorter lengths are also used. Now, change in width normally should be effected over a length of 30 to 60 meter as per the recommendation of AASHTO. AASHTO states that it should be done over a length of 30 to 60 meter, neither too long nor too short a length. From the standpoint of usefulness and appearance, the edge of the travelled way through the widening transition should be a smooth, graceful curve. This is very important, which is often overlooked, because we provide transition curve for a specific reason, and transition curve is a curve. So, therefore, when the extra widening is also introduced, it is necessary to have a smooth, graceful curve at the outer edge. The appearance should be like a smooth, graceful curves, not a tangent transition edge. Okay. Now, with transition curve, widening is generally applied equally on both sides of the carriageway, 50% on the outer side, 50% on the inner side. Without transition curve, the entire widening should be done only on inner side and also on sharp curves of hill roads. There are other practical constraints also. The entire widening may be done on the inner side. Now, let us quickly see some of the general controls of horizontal alignment. Many of these things we have also discussed earlier when we talked about the design of other components. So, horizontal curves, transition curves and other things, but related to horizontal alignment, what are the general controls that should be kept in mind? First, alignment should be as directional as practical, but consistent with topography. Number of short curves to be kept minimum. However, long tangents are also needed, because we have to provide adequate passing side distance, particularly for two-lane undivided roads or highways. Therefore, long tangents are also necessary. In alignment developed for design speed, attempts should be made to use flat curves, saving the minimum radius for the most critical condition. Not that we shall design the curve with minimum radius, acceptable radius. We should try to provide flatter curves and keep the absolute minimum or the sharpest curve for the critical conditions or the critical situations. The alignment should be consistent, that means sharp curves should not be introduced at the end of long tangents. We have mentioned it earlier also. For small deflection angle less than 5 degree, curve should be sufficiently long to avoid the appearance of kinks. This appearance part is also very important. We must try to avoid the appearance of kinks. So, both AASHTO and IRC recommends that curve length should be at least 150 meter for a deflection angle of 5 degree. That is what we are calling a small deflection angle, and this should be increased by 30 meter for each 1 degree increase, each 1 degree decrease in deflection angle. That means, for small deflection angle up to 5 degree, that means for 5 degree it is 150 meter, for each 1 degree decrease in deflection angle add 30 meter extra length, just to avoid the appearance of kinks. Then caution should be exercised in the use of compound circular curves. We should try to avoid it, but for safe and smooth transition from one curve to another, the radius of the flatter curve should not be disproportional to the radius of sharper curves. There has to be some sorts of compatibility, and therefore, a ratio of 1.5:1 should be considered as the limiting value. A ratio of 1.5:1 should be considered as limiting value when compound circular curves are used and one is flatter, another is sharper. So, that should be the limiting ratio. Reverse curve normally should be avoided, but wherever the situation demands, one has to maybe accept reverse curves, especially in difficult terrain, but it should be ensured that there is sufficient length between the two curves for introduction of requisite transition curve. Now, sharp curves should be avoided on long high fields, and curves in the same direction separated by short tangent, what is known as broken back curves, should be avoided for aesthetic as well as for safety reasons, and they should be replaced by a single curve. Now, we have told or I have mentioned that we need long tangents, particularly on 2-lane 2A roads, to have adequate passing side distance, but very long tangent sections also should be avoided. Very long means say exceeding 3 km in length. A curvilinear alignment with long curves is better from point of view of safety and aesthetics rather than a very long tangent sections. So, from safety point of view, this is essential. Finally, to avoid distortion in appearance, the horizontal alignment should be coordinated carefully with the longitudinal profile, and it should be kept in mind that road is a 3-dimensional entity. It is not only the horizontal alignment, but also the vertical alignment, and the coordination of horizontal and vertical alignment is also an important consideration. Some of the questions for you to answer: explain the need for providing extra widening at horizontal curves, explain the basis for design of extra widening as per Indian Roads Congress, explain the basic components considered in AASHTO for the design of extra widening, and try to solve this problem or try to calculate the required extra widening as per Indian Roads Congress. If the pavement width is 7 meter, radius of the horizontal curve is 200 meter, and design speed is 70 km per hour. Now, let me quickly try to give answers to questions of lessons 3.1. The first question was: explain the basis for obtaining the minimum length of super elevation runoff. It is basically based on the relative gradient. Therefore, that means there has to be a maximum acceptable difference between the longitudinal grades of the axis of rotation and the edge of the pavement, that is the relative gradients, for better appearance and comfort. Now, relative gradient is also a function of design speed to have longer runoff lengths at higher speeds and shorter length at lower speed. Now, explain the basis for calculation of minimum length of spiral transition curve. It is calculated based on driver's comfort, that means maximum change of lateral acceleration, normally a value of 1.2 meter per second cube is taken. Considering this maximum rate of change of lateral acceleration, what should be the length? This is the equation what can be used for calculation of the length. So, one aspect is the driver comfort or maximum rate of change of lateral acceleration. The other aspect is the based on the lateral shift, because to ensure that a spiral curve is sufficiently long to provide a shift in a vehicle's lateral position within its lane that is consistent with that produced by vehicle's natural path. So, here P minimum value is used as 0.2 meter. This is consistent with the minimum lateral shift that occurs as a result of natural steering behavior of most drivers. So, considering that lateral shift, what should be the minimum length of the curve, and the higher of these two values should be accepted. The last question was, explain the significance of considering an upper limit of the length of spiral. Why an upper limit is used? Basically, safety problems may occur on spiral curves that are very long. Very long means very long relative to the length of the circular curve. As compared to the length of the circular curve, if the transition length is very high, then safety problem may occur, because that may mislead the driver about the sharpness of the approaching curve. So, therefore, considering lateral shift when we calculated the minimum required length of spiral, a similar formulation is used here, suggested here, but the maximum lateral offset is taken into consideration, which is taken as 1 meter, and this P max as 1 meter is consistent with the maximum lateral shift that occurs as a result of the natural steering behavior of most drivers. Also, this 1 meter P max as 1 meter provides a reasonable balance between the spiral length and the transition curves. So, that is why a upper limit of spiral, upper limit of the length of spiral is also considered and meaningful. Thank you.